Alright, so today we're going to be doing the project walkthrough for React American Football, which is our first React project, and I'm very excited to get to it. So I've already forked and cloned the project here, and I've downloaded it to my computer. We can see when I type ls, I see our package.json, the source directory. This tells me that I'm in the right place. If you want to know where you are in the terminal at any point, you can type the command pwd, and what that's going to do is it's going to print out the current path you're at. So see, I'm inside of this project. So our first step to get this running is to do yarn install or npm install. This is going to go and fetch all the dependencies listed in our package.json, and this can take a bit. When we do these React projects and in the state of modern React's development, we end up using a lot of dependencies, and our dependencies use a lot of dependencies. So that took 14 seconds, which is fairly long. But now we have all of that installed, so we can run yarn start. We're not going to be using live server or any of the technologies we used to previously view our stuff. When we run yarn start, it should open up in our tab in our browser at localhost 3000. Localhost always refers to your current computer, and :3000 is going to be the port. So there's a server on our computer that is accepting requests over the network, but the way it's laid out is that each program needs to be able to listen in a different spot. So it knows, okay, I want to talk to the program that's giving me my React stuff. And the way that works is these numerical ports. When you go to a website normally, you're actually using port 80. That's what we do HTTP on. Or port 443, which is what we use HTTPS on. So for now, I actually want to do this in Firefox because that is my preferred browser. Oh, and I wanted to start hiding my bookmarks toolbar. How do I do that? Toolbars, yeah, okay. Just because I don't want that distracting anyone in the videos trying to figure out my favorite websites. So here's our project. Nothing works right now when I click these buttons because we're starting from scratch. So I'm going to go into source and then app.js, which is where our React projects really start in terms of the functionality. If we look inside of index.js, this is where the setup happens. Notice that we're importing React, we're importing another library called React DOM, and we're running React DOM.render on our app components, and this is the only place where we actually interact directly with the DOM. This document.getElementById root. So this is going out and getting in the page a div that has the ID of root in it, which we can see right here, and then React is rendering our entire component inside of here. If I was to delete this div completely, can I do that? I can. This is actually what our React page starts out as when we first load it. It's just this empty div with an ID of root in there. But then React handles and going and rendering our app to it. So we actually want to write our app that does things. So I'm going to go in here, and step one is to import the useState hook. Now, thankfully today we talked a bit more about named versus default exports. So I'm doing a named import on the useState function from the React library. Now I want to establish my application state. So in this case, I'm going to need at least two state variables. One for the score of the Lions and one for the score of the Tigers. And to be more generic, I'm going to call these home and away teams. That's what we do in some of these other identifiers, so I'm going to stick with that. So the way we use useState is this funky looking syntax. And I'm going to turn line numbers on. So the way this works is useState is a function, and it accepts a single argument. and that's going to be the default value for the stateful variable that we're creating. In this case, I'm calling that variable home score, and the corresponding function to set that variable's value, set home score. I can call this whatever I want, set banana if I wanted to, but traditionally we call it set and then whatever the variable name we used was. What's happening here is destructuring. I've gone over this a couple times in some of the other walkthroughs I've done. Would anyone like to see another refresher on how destructuring works?
Yeah, that'd be great.
Okay. So the way destructuring works, I'm going to open up a REPL here. So let's say I had an array with 1 and 2 in it, and I wanted to define a variable a equal to the value in the first position of that array and at the 0 index. I could do this, and then if I wanted b to equal the array at 1, I could do that. And you know, a is going to be 1 and b is going to be 2. But this is kind of long-winded. Thankfully, JavaScript has a syntax called destructuring, and this allows us to put our variable names inside of a data structure on the left-hand side that we're going to see on the right-hand side. So what's happening here is a, the variable a, is going to be set equal to 1 since they're in the same position, and the variable b is going to be set equal to 2. And I can change these values just to make sure that this worked. So if I check a is going to be 3, and b is going to be 4. And so what happens when we call useState is I'm going to console.log what happens when I call useState and giving it 0. So if we look in our console, what we're going to see is, oh shoot, the recording has been on my big dumb face this whole time. Well, I apologize to everyone for that. So what we see is it's an array of 2 values, 0 and a function. So that's what we're destructuring when we use this syntax here. We're destructuring the array home score, which is the value of our variable, in this case 0, and then the function set home score. Does that clear up destructuring for you?
Yeah, I think so.
Okay. So now I have my home score set up, and I'm going to do the same thing for the away score and just do some copy and paste and replace magic. So now I have 2 variables, one for the score that my home team has and one for my score that the away team has. And I want to insert these into the page. Instead of having these hard-coded values of 32 in here, I want to use these variables that I've set up. So we have a method to insert JavaScript into our page, and that is the curly brace syntax. And home score is just like any other variable. It's just a const variable. So I can insert it into the page. Same with away score. So now when I save this file, my browser should refresh, and I should see that we now have zeros set up in there. But I don't want these to always stay 0. Part of our MVP is getting these buttons to work, and that'll set the values of these to the increased number of points we score when we get touchdowns or field goals. So the way we do this is by looking at these buttons down here. So normally in vanilla JavaScript, when we would write event listeners, we would do a document.querySelector.add event listener, but we can't do that here. So what we do is we use an attribute version, and this is actually present in vanilla JavaScript. If I do mdn onClick attribute, we can, inside of our normal, is this the page that I want? Yeah. So we can, inside of normal HTML, write onClick equals and then some JavaScript we want to run when we click on that element. And so that's the style that we use in React. So I'm going to add an attribute, which we also call a property in React, of onClick, and I want this to run some function when I click on it. Now, some of you might have run into errors where you started typing your function and now I'm getting syntax errors. Because I'm going to write JavaScript, I'm going to write a function, I have to do curly braces. So when I click on this button, let's just check and see if it works. I'm going to do a console.log and say clicked. So when I click on this, we see that that runs. It runs my function, right? Just like any other event listener, this expects a callback function. If I had done this, if I had just said console.log click, watch what happens. When the page loads, clicked gets run. But when I click on this button, nothing happens. That's because what we do inside of curly braces is expressions. We put expressions in there. So previously I had a function. So when that code was run, it created a function. And then whenever we clicked on this button, that function was run. But the way this is set up now is that React is going to go through, it's going to parse our page, it's going to see these curly braces, and it's going to try to run whatever JavaScript is inside of there. And it's just going to run this console.log the first time we render our page. When we click on the button, nothing happens because this doesn't, have any function to run. Console.log is just going to return undefined. So I have to wrap this in a function because I want onClick to be able to execute this when it decides, not when our page is rendered. So instead of doing console.log, I want to increase the score of the home team. So I can use my setHomeScore function. I can call setHomeScore, and then I want to add 7 to the home score. Just do HomeScore plus 7. So now, when I click on this button, we see that we have not only increased that home score value, but our page has displayed those changes. And this is so nice. This is such a nice thing. Because the way this has worked is when we call setHomeScore, it's going to tell React, okay, re-render this component. And so it's going to rerun this component, and this time home score is going to be set equal to 7 or 70 or whatever. And so this value of home score here is going to be updated, and that's what's going to be displayed on our page. React handles this whole process of displaying this stuff on this page for us. And you'll see every time I click on this button, the console log that I wrote here runs again. We're just getting more and more of those. That's because to re-render the component, this is a function. React is just going to run this function again. Does that make sense?
It does for me. I don't know about everybody else, but I got it.
Okay, great. So now I have that working. I'm gonna try to get this working for the other things, and I can do this with some copy and pasting. When we have these properties running off the side of our page here, what we can do is just put them on new lines. And so I'm gonna try to organize this just so it looks a little bit nicer. So now I want to add the field goal functionality. So I'm going to do that right in here. I'm going to add it as a prop to this button. This time I want to increase the score by 3. And let's go ahead and do that for the away team as well. Or I can just paste that. And this time I'm going to change home to away. Format this all nicely for us. And get that there. This time, that needs to be 7, that needs to be 3. There we go. So let's check and see if this works. 7, 10, 7, 10. Yep. Alright, so these buttons are all working. And again, notice every time I click one, it causes our entire component to re-render. It causes this whole function to run again. So does anyone have any questions on this? Alright. I'm assuming we're good here. Or, wait, do we have a question?
Henry, where's that console log that's logging the whole re-render?
That is happening right at the top of our function. We put this use state in here. If I want, I can have this say render, so we, you know, see that running each time. But now we just get like this little number increasing. I kind of liked how we saw the line adding at each step. Yeah. So now I'd like to move on to the stretch. So let's see. Yeah, let's break these out into components first. Then I would like to do the scoreboard timer, and then if there's time, I would like to do this handler function. So let's break these into components. So the way this works is it's luckily not that difficult. So I'm going to look at our current directory, and I'm going to see all these files. I want to make a new one and call it, let's do the scoreboard. All right, the scoreboard is a nice logical chunk of stuff that's happening that we can relate together. So I'm just going to create a file called scoreboard.js. I'm going to import React from React on the first line. Even though we don't use React, we have to import it to get JSX to work. I'm going to declare a function called scoreboard, and then I'm going to export default scoreboard, and here I want to return, and inside of this set of parentheses I want all my JSX. So I'm just going to go and I'm going to steal this. So a couple things. My text editor is nice enough to highlight to me what isn't defined currently. So we have these two variables, home score and away score, that aren't defined. And we also have this component bottom row that's undefined. Well, I can fix bottom row. That's just because that's a component that we didn't import. So I'm going to import that here. So that's fixed. But now I have these home score and away score variables that aren't defined. So let's import this component into our app component. So we do that, import scoreboard from /scoreboard.js, and then I can use it just like any other tag inside of our JSX. So now our page is going to re-render, and we're getting errors. React has pretty good error messages, which makes our lives as developers a lot easier. So it's telling us home score and away score aren't defined. And that's because they're defined up here. They're defined in app. So we need to pass them down into scoreboard. We can do that using props. So the way we would do this is I would say home score is going to equal home score, and away score is going to equal away score. And then I add an argument to my scoreboard component called props. I'm going to console log props in here. And for now, I'm actually going to delete these so I don't get an error message. So what I see when I console log props is an object that has two keys, away score and home score, and they're both equal to 0. And when I update them by clicking these buttons and changing the score, notice that we're re-rendering our scoreboard component. And if we can't see those numbers right now because I don't have them inside of the JSX, but we can see that they're updating automatically in our props object. So here's how the props object works. I can call these whatever I want. Let's say left score and right score. Because what this name is here, that's going to end up being the key inside of my object. On the right hand side, I'm using this variable home score, so its name matters. Its name has to be the name of this variable up here, because that is what has the data that I want in it. But I can call these property names anything that I want, because when we reload our page, we see this object, but now the keys are left score and right score. I want to emphasize here that this scoreboard component is a function. So what this JSX syntax is actually doing is it's calling our scoreboard function, right? Scoreboard is a function. We can invoke it like any other function. We just have to do it inside of curly braces because it's JavaScript. And then the way the props object works is all of these attribute looking things are collected up into one large object where the name on the left hand side is used as the key and the value on the right hand side is used as the value. So these lines of code are doing the exact same thing. These are the exact same lines of code, essentially. And if we look, we'll see that, we now get console log this object twice, and we see our component twice because we're rendering it twice. This is what our JSX is doing. It just allows us to write in a format more consistent with the way we write HTML. So,
yeah, Henry?
yes.
Okay, so you're saying the lines 15 and 14 are identical?
Could you repeat that?
So you're saying line 14 and 15 are identical?
Yes, essentially. What this line of code is doing is it's rendering our component. We say render, but what do we mean? We mean running it. This returns the JSX. So to get that, we run our function. That's what rendering means in this case. And we're giving it these property values, these props. And what happens is these get translated into an object that we take as the first argument to our function. And I'm console logging this object here. We can see what it ends up being. So these lines of code end up being equivalent, where here we're just manually making this props object, but here I get to write it in this HTML looking format. And these ultimately get transformed into keys and values inside of the props object. And I can put whatever I want in here. I can put a 7, I can put, some string. I can give this a function. I can give this like set home score, because I can pass in any values that I want here. Inside curly braces I'm doing JavaScript, so I could give this a function. But I want to give it my values, home score and away score, because I want it to show them on the page. So I'm going to replace left with home for the sake of consistency. But know that we can call that whatever we want. And I'm going to replace right with home. Or, I'm sorry, I want to replace right with away. And I'm going to comment this out. So now we have access inside of this props object to the home score and the away score. Right, I see them here. Our object, home score, and away score. So I can access those like, we would access a normal value out of an object. So inside curly braces, I can do props.homescore, and I can do, where was it? Right here. Props.away score. So now these are going to show up. We see our props object console logged here. And when I click this button to increase those values, it still works. And we can see that's because we're re-rendering our app component, which in turn is going to re-render the scoreboard component, which is getting the updated values of home score and away score. So even though we've moved it outside of, app into its own component, we're still using it in app. So it's still being a part of that re-render cycle, and it's getting the updated values of home score and away score. Any questions with this? All right. So now I want to touch on destructuring, because we talked about this in lecture, and I want to make sure that the syntax doesn't feel too alien to you. So we previously talked about destructuring arrays. So if I go back to my REPL here, I destructured this array using this syntax. We can also destructure objects. So instead of using square brackets, we want to mirror our data structure on the right hand side. So I'm going to do var a comma b and set this equal to an object with a key of a set equal to 1 and a key of b equal to 2. So what this line of code is going to do is JavaScript is going to go and look for a key of a on the object in the right hand side, and then set a variable a equal to that value. And it's going to do the same thing with b. So when I run this code, a is now set to 1, and b is now set to 2. If I do this, if I do c:3, what's the value of the variable c going to be?
Nothing.
Nothing, right? I don't have a c on my left-hand side, so JavaScript isn't going to be care. We still just have a, b, and c is not defined. I could add c on my left-hand side, and now c is going to be 3. This is how we do object destructuring. And props is an object. So I can use that here. So instead of doing props.homescore and props.awayscore down here, I could do something like props or const homescore is equal to props.homescore and const awayscore is equal to this. But if I'm starting to have a lot of props, and you're going to quickly run into cases where you're passing down 5, 10 properties to one of your components, this is going to result in a lot of lines of code. So instead, we can use the destructuring syntax. Homescore, awayscore is equal to the props object. So this line of code is going to look into our props object for, I want this console.log back, I didn't mean to delete it. It's going to look in the props object for a key called homescore and set the homescore variable equal to its value, and the same with awayscore. And now I can use them like normal variables.
Now, Henry, what if you swap the value, the variable order in your constant declaration?
Great question. Everything is still going to work fine. Because unlike arrays, objects are not ordered. There's no default order that those elements are in. In the array destructuring, the position of our variables was important, right? The fact that this a was here is what made it be equal to 3. The fact that I named this a didn't matter, because names have nothing of importance inside of our arrays. But in our object, the position doesn't matter. I can shuffle this around and do C, A, B, and I get the same result, because the way this is going to work is JavaScript is going to look for a key called C in the right hand side and set C equal to that value. So the position doesn't matter, now the name does. So now we have our props, and you might be wondering what the advantage of doing this is. Dan talked about it in lecture. So when I start having 5, 10, 15 props being passed to my component, it's going to be hard to figure out what exactly they are. Especially in your next build week, you're going to be collaborating with a React project with other people. So they're going to be writing components that you don't fully understand. And so it would be really nice if you could look in this file and then immediately see at the very top, oh, okay, this takes these props, away score and home score, as opposed to having to search for props and then read through the entire file to try to figure out what props are used. That's really nice. It makes these feel more like arguments. Now, what we can do that's really trippy is we can do destructuring directly inside of our argument list. So instead of doing this line here, I can put it right in there. And this replaces the props object with a direct destructuring, so that when we're given this object as an argument, JavaScript is going to immediately destructure it and give us variables away score and home score. If I console log props, props isn't defined. So we can use this to treat these visually much more like function arguments. And that's nice because it lets us know what data this component needs to work right off the bat. And that's good. We could have a comment at the top, explaining exactly what all the properties are. But the issue with that is that it's easy for a comment to become out of sync with our code. We could update one of the prompts and not update the comment, and that's not going to cause any tests to fail or our website to look different. But doing it this way guarantees that this is always up to date with the props that we're using. So there's no inherent advantage to doing it in the argument list as opposed to on the next line. If I just have a couple of props, I'll usually do it in the argument list. But when you start having a ton, and this line might start running towards the edge of the screen and wrapping around, if you do it down here, you can always change how this is formatted and make it look a little bit nicer. So I tend to use this on the first line when I have a ton of props. If I have one or two, I just put them right in my argument list. That's at least my preference. So now, do we have any questions on this? Alright, if there are no takers, I'm going to quickly go out and do the buttons in their own component. So again, I'm going to create a file, button.js, and I'm going to import React from React. And then I'm going to declare a function called buttons. It's going to take an argument called props. And I'm going to export default buttons. Now I'm going to go ahead and grab all of the JSX that I want to display in here. Toss it in here. Now we see we have a bunch of undefined variables. So what I'm going to do is I'm going to import that from its file, buttons.js. And I'm going to use that inside of my React app. We can see that now this is a little bit cleaner, at least. When we look at the app, we can see what's going on at a glance. Okay, there's a scoreboard and there's some buttons. Instead of having this huge mess of JSX. Of course, we didn't get rid of it, we just moved it into another place, but gaining this visual clarity is helpful. Alright, so now we're getting errors because all of these variables are no longer defined. We no longer have set home score and the corresponding ones for away score. What can I do? I can pass those down as props. So I can say home score is going to equal home score. I'm going to say away score is going to equal away score. But now I have to add the functions. And I do that the exact same way. Because in JavaScript, functions are like any other kind of data type. I can pass them around like numbers, like arrays, like whatever. I can just, you know, give this function as a variable to this, as an argument to this. So now, if I go inside of buttons and I console log props, oh, it's getting mad at me during the import stage, so I can't do that. But if I wanted to, I could go out and I could change all of these to props.whatever. Or, another advantage of destructuring is that I can reuse those same variable names. So I can get home score, set home score, away score, set away score, directly out of my props object. And then now, this is all going to work, and I don't have to add props.whatever to anything. Any questions with this?
So I had a question, not pertaining to this, but to the stretch the timer.
Okay, yes, we're going to do the timer next. So if there are no questions with this, I'll move on to that one. I want to have a brief discussion about where we put our state. So if I tried to put my... Yes.
Before you continue on,
Yes.
is there a way for you just to give me a snapshot of that code? Because I'd like to compare that to mine before you complicate it with the...
Absolutely.
Thank you.
So I will commit these completed MVP and components, and I will push this up to the GitHub, which is, I'm going to start trying to do this from now on, is having this inside of a, oh, I need to do that over here, having this inside of a GitHub repository so I can push and reference this code, and you'll have it when I'm done. So that'll be here, and then I will make a branch. Let's do that. Okay. So now I have a new branch for the timer in it. So if you're looking for that code, that'll be in there. Alright, so I want to have a brief discussion about state and where we should put it. So if I put the state inside of my buttons, because hey, this uses all of this stuff, we immediately see a problem happen. And that's that Scoreboard no longer has access to these values. Because in React, we can only pass data in one direction, at least initially. So we pass props down, right? If we think of our components as a tree with app at the top, and then we have Scoreboard, and we have buttons, we can only pass props down. I can't pass props from buttons over to Scoreboard. There's no way for me to do that. So where we tend to put state is high enough that we can pass it to every component that needs it. In the case with these small or focused projects, that's going to mainly mean doing it in app. But if we have a component that has some state in it that only that component relies on, or only components beneath it relies on, it's fine to keep that state in there. Because if we put absolutely all of our state in app, then app is going to be enormous, and we're going to have to pass props like 10 layers down sometimes to get it down to the component that needs it. So if we know state is going to be local to one component, we can leave it in there. But if we need state to be shared between multiple components, we need to make sure that state is going to be high enough in our component tree that we can pass it down to all of the components that need that. So let's do the timer with that in mind. So I'm going to open up my, I guess I'll save this file. I'm going to open up my scoreboard.js because that's where my timer is. And I'm going to replace this timer with its own component. So I'm going to go ahead and create a file called timer.js. I'm going to import React from React. And then I'm going to create a function called timer. It's going to accept props. I don't think it's actually going to use any at this point. And then I'm going to export default timer. Inside of here, I'm going to return, inside of a set of parentheses, the JSX I would like to use. Now, inside of this component, I can import timer from /timer.js and then use it right here. Great, so that works, and let's change this just to make sure that... Awesome. So now that's all hooked up. Now I have to figure out how to get a timer to run. And I'm going to make the executive decision here that only this timer needs to care about how that works. So I'm going to leave all of the state in timer. So I'm going to make a stateful variable called time and its setTime function using my useState hook, and I want time to start at 15 minutes and count down. 15 minutes is 900 seconds. How do I know that? Because I'm so smart. I am so very smart, and it is not because I've done this like 4 times now and have it memorized. So I need to also import my useState hook so that I can use it. And now I can render my time here. Great. And it just says 900. We'll figure out how to get it into minutes and seconds in a bit. For now, I'm fine with it just being in seconds. So we want it to tick down. What we're going to end up doing is mostly the same from the way we would have implemented this timer in vanilla.js, because the underlying logic for how to make a timer doesn't change too much. What's largely going to change is our syntax for how we set and display state. So if I want some process to occur repeatedly, there's a function in JavaScript called setInterval. And we can use this in vanilla JavaScript, and we can use this in React. What it does is it takes as its first argument a callback function, and then as the second argument a time in milliseconds. And whenever this amount of time has elapsed, we run the callback function. So I can use that to decrement our time. So I can call setInterval, and I'm going to give it a callback. And I'm going to get this syntax error saying it's not declared. It is. My editor just doesn't know that. And so every second, every 1,000 milliseconds, I want to set my time to be 1 less. Let's see if this works. We get 899, 898. Whew, I'm a genius. This works perfectly. I'm done. We can all leave. Except this is starting to freak out. Does anyone know why this is freaking out so bad?
Yeah, I ran into the same issue. I was wondering the same thing, and my guess is that it's because you're trying to manually adjust the DOM, and React does DOM manipulation by itself. Could that be the answer?
That's not quite it. If I add a console log in here that says render timer, we're going to see that that starts happening every time we update this time. And then it starts happening a lot. We've rendered this timer 2,000 times already, and this is getting out of hand. And that's because whenever we do set state, whenever the data that our component has changes, React needs to re-render it. How does it re-render it? It reruns the entire component. So every time we change the data, it's going to run this set interval again. And so we're going to add another process ticking in the background every second is trying to set the time -1. And you can see it's fighting. We're flicking back up and down as these various timers kind of compete with each other. Because now we're up to... Are we at the hundreds of thousands already? I mean, this is just going insane. So what we need to do is we need to find some way of running this set interval only one time. The solution for that in hooks is another function called useEffect. UseEffect is going to have a very similar syntax to setInterval. useEffect takes as its first argument a callback function, and as its second argument, it takes an array of data. The way useEffect works is whenever any of the values in this array changes, useEffect will run the callback function. So a common use case for this is, let's say we have a component that displays a user's page on like Facebook or something. And we do that by fetching data from an API using that user's ID. Now what we can do cleverly is with useEffect, whenever that ID changes, I can go out and I can fetch the new user data and display that. So I can trigger events to happen whenever some data changes. In this case, I only want something to happen once, and so the trick is we give useEffect an empty array. Because that data will never change because it's nothing and will always be nothing, it's going to run once, the first time we render our component, and then no other times. So if I put this set interval in here, and then add a console.log first render, you know what, let's leave this set interval out here and just have a console.log in here that says first render. So now, even though we're rendering this component over and over and over again, we never see first render get printed again. useEffect with this empty object will only run once. We can have as many useEffects as we want in this function too. If I want to have some other stuff that triggers when data changes, I can do that just fine. But I only want to do this once, and I only need one useEffect, so that's all I'm going to do. So now what I'm going to do is I'm going to put this set interval in useEffect, because I only want it to happen once. And let's see what happens. We get 900, we get 899, I'm a genius, except the timer has stopped. And this right here, why it stopped at 899, is one of my favorite things. If you understand this, then you understand React on a very deep level, especially for your second day of React. So, let's check and see what's happening here. I can see we re-rendered our timer twice, and then we stopped doing that. We did do our first render. I'm going to add a console.log in the set interval, because did this only run once for some reason? I'm going to call this interval, and let's see what happens. Interval keeps running. We keep seeing this get printed. So this is running. But let me console log time along with that. Time is always 900. The reason that time is always 900 is because when we use our state here, we're setting time to be a const. We know from normal JavaScript that you can't change the value in a const. We can't reassign it. So what our setTime function does is it re-renders our component. And the next time this whole function is run, during that re-render, useState will assign time to be the new value. So we're not actually changing the value of the time variable inside of our function. We're calling the function again and setting the value of time in there to a new value, where it will be that new value, and it will always be that new value. The values of these variables never actually change inside of their function scope, inside of that render of the component. Whenever we need them to change, we re-render an entirely different version of the component, where that variable is and always will be the new value. Because what we're doing here is we're always running 900 minus 1. Because when we define this callback function for the set interval, we're only doing that during the first render. And in the first render, what's the value of our time? It's 900. and it will always be 900 because this this callback function here is accessing a variable outside of its scope. And what do we call that? That's a closure. Ooh, we can't abandon all the things we've already learned just because we're doing React now. All of this stuff adds up. So in the closure of this set interval, time is 900, and it will always be 900. So how do we get around this? Well, luckily, the developers before us have run into this issue, and they wanted to know how to fix it. And the solution is, instead of giving set time a value that we want it to set time to, we can give it a callback function. And this callback function takes a single argument. And set time is going to provide to us as that argument the most current version of time. It's going to provide the most updated value of time that it has. And so we can use that to make sure we're getting the newest value of time and subtracting that by 1. And so I'm going to, inside this callback function, add a console.log so we can see exactly what's happening. I'm going to console log our old time and then our new time. The time we're getting from this console log. So we see now this new time is ticking down and our timer works. But our old value of time, the constant variable time that necessarily cannot change, does not change. This is awesome. This is confusing. This is hard to wrap your head around, but it's awesome. So, what are the questions we have about this?
Yeah, I mean, I appreciate you breaking it down like this. But like, when you pass a callback into set time, why is time allowed to mutate? And when you just try to do it with time -1 without the callback, it's not allowed to mutate. I don't understand that distinction.
Mutation is never recurring. At least within like what we can see. Mutation is not happening. Time is a constant value. What our useState function does is behind the scenes, when we call setTime and we give it a new value, what it does is it says, okay, the next time you call this useState, instead of returning 900, I'm going to return 899 or 816 or whatever. And so that variable of time within the scope of that function is going to be the new value. Inside of our original first render function, time is going to be set equal to 900 because that's our default value, and it's never going to change. So we don't have mutation happening in any instance of our function rendering. Time is just getting set to a new value magically, somewhat, by useState. The way that works behind the scenes is rather complicated, but it works. So
and that's why we're not allowed to manually change the value of time. We have to use the function set time.
Yeah, that's why I would not do something like, you know, time minus minus or time minus equals 1. I can't update the value of this variable. That won't work because I would be doing it inside of this function. And if the data changed, then we'd re-render the function, which would run the function again, which is going to reset its value from useState. So I have to use our special setTime function. And it's going out and it's getting new time when I give it this callback. It's getting it from its special store that it has in the background that knows the next value of time that it's going to return. Right? Because when we re-render this function, useState is going to be returning a new value that we're setting time equal to. And so that's what we're accessing here. And I can call this whatever I want. I just chose new time. Often you'll see it written like this, just all on one line. We'll just say, you know, time minus 1 and we'll call this variable time. This just makes sure we're getting the updated value of time instead of the stale one that we have in our function.
So, Henry, the relationship between the original hook of set time and its value time and what it is now inside set interval, you can call it whatever you want because it's replacing that original value with whatever this new value is.
Yeah, in the same way, this is one of the ways we handle scopes, is like I can make a constant variable called time up here, but when I make a new variable inside this function scope, I mask it. So it's just going to pretend that this global variable doesn't exist and let me make a local variable with the same name. And that's exactly what I'm doing inside this function. I'm just making a new local variable that happens to have the same name as time. And I can make this new time if we want to be more clear about what's happening. But you won't always see it that way, so I want to make sure that you're exposed to it while we have time now.
Yeah, I mean, what you're saying makes sense. I mean, if you pass in a callback to set time, it's going to magically have the latest updated time, but I don't really understand why it wouldn't work without a callback. I mean, if you're calling set time as a function should, update time without mutating it. So, I mean, if that's what set time does, then why do you have to pass in a callback to get the latest
Because
time?
let's console log in here time -1. Its value is always going to be 899 over and over and over again. Because what is the variable time? Time, the first time we run this function, is 900. And in the first time we run this function, I am making this set interval. And in the first time we run the function, when I reference this variable time, it's 900. So when I call set time with time -1, that's going to be 899. And so set time is going to re-render the timer component. But this time, inside of that component, time is going to be 899, and it got displayed, and that worked. But the problem is, when we do it this way, it's 899. 1 second later, set interval ticks again. And when it does, the value of time inside of our callback function never gets updated because it's inside of that function's closure, right? While it seems like this function should be able to grab the updated value of time here, it can't, because we already declared this function once, and only once, the first time we render. So this never sees the updated variable of time. That never happens. In the same way, if I declare a variable called first time and set it equal to time, this variable is going to be equal to 900. And if I use that, maybe it's a bit more clear, this will always be 900 because our console log of first render, we can see that only happens once. That only ever happens once. So we're only ever setting this variable first time once. And when we do that, it's 900. And so always inside of this set interval function, first time will be 900. This is what's implicitly happening to the variable time.
Okay, I mean, I think that makes sense.
Okay.
Yeah, that makes sense. That it's a closure, basically.
Yes.
At the time that set interval is run, it's accessing the time variable, and the time is that's its closure. So it's going to always keep that value. It's going to maintain that value. That makes sense to me.
Yeah. Great. Yeah. Exactly. That's exactly right. Time in the set interval's closure is going to be 900. So that's why we have to use the callback version. where we get the new time, and then we do new time -1. I'm going to clean up some of these console logs before I publish this.
So when will the actual time be updated? Will it be updated when the component is rerun?
So,
or the function is rerun?
What happens is, quickly, I'm gonna show how this works. So we set the new time every second. So every second our component is gonna re-render, and inside of it, time is gonna be the new value, which is why our component updates. And if I console log this time, we see it ticks down. Every second we re-render the timer, and the variable time gets defined to be whatever that happens to be. So, if I want to calculate the minutes and seconds and display this in this timer, I can do this just inside the function, like normal. Because every time the time updates, the whole function is going to get rerun, and I'll recalculate the number of minutes and seconds. So let's do that. I want to calculate the seconds, and I can do that by doing time mod 60. For those of you that haven't seen before, the modulo operator is an operator that performs a division. In this case, we're going to divide by 60, and then it's going to give me the remainder. And so that will tell me how many minutes or how many seconds are left over from the minute. I can do a similar thing with minutes. I can divide the time by 60 to get the minutes, but I'm going to end up having a decimal at the end of this. I can drop that using math.floor. And I'm going to be a bit brief because I've run over lunchtime, so I don't want to interfere with your project time. So now I can put minutes here, colon, and then seconds. And so now we'll see that that updates. Right? Because every time we re-render this component, time is going to be set equal to a new value. And so then seconds is going to be calculated based on that new value of time. Same thing with minutes. And so now we have a timer that ticks down. The one problem is that we can see initially this 0 isn't double 0. It's a single 0. So I want to real fast show how you do that. We can convert this into a string and then use a string function called pad start. So what pad start does is it takes two arguments. It takes a number and a string. And what it says is when we call it on string 1, which is going to be 5, I say I want the resultant string to always be 2 characters wide. If it's not, add zeros to the front of that string until it is 2 characters wide. So if our input is 5 here, our output's going to be 05. If the input was 25, it's going to stay as 25 because that's already 2 characters wide. So what I can do is I can convert this to a string and then use pad start to make it 2 characters wide and add a padding 0. Same thing here, to string, pad start, 2, and 0. So then now, if you see, right when we refresh, we get that double 0. And so now we have our nice timer working. So, any questions with that?
Just want to say, Henry, amazing stuff. I really appreciate this stuff. It's really mind-blowing.
Thank you. I'm so glad.
And it gives you really a deep understanding of it. So it's awesome.
Oh, well,
yeah, man, you go above and beyond. So you're a rock star. And I look forward to rewatching this video.
Yes.
Even though I went through it last night, I'm still, you know, like vaguely, slowly, my brain catching it.
Mm-hmm. And I apologize to anyone watching the YouTube video. I'm using not the Zoom recording, but a third-party recording, and I accidentally had it set to the webcam view for like the first 5 minutes, so it's just gonna be a big picture of me. Luckily, I catch it before we start writing any code, but you are gonna have to skip through a nice webcam view at the start. So. Thank you all so much for coming. I have a blast doing these, and I will see you tomorrow.
Thanks, brother.